Math Blast 6, I can generate and analyze patterns. What would be the 15th shape of this pattern? How can you determine the 15th shape without drawing onto the pattern? I notice that the pattern is created by three terms: a circle, this plus sign, which I also know is called an irregular dodecagon, and another irregular dodecagon. Before the pattern repeats: circle, irregular dodecagon, irregular dodecagon. So I know that 15 is a multiple of 3. 5 groups of 3 is 15. 5 times 3 equals 15 is basically what I just stated there. So I know that the third shape in the 5th group will be the 15th shape. So once again, the third shape in the 5th group will be the 15th shape. So the third shape in any group is here, this irregular dodecagon. So I'm going to state it will be, and I'm just going to sketch that out here. And it does not need to be perfect, just enough to get our point across. And there we are. I can compare numbers in standard, unit, and expanded form. Use the correct relational symbol to make each sentence true. I'm first given two numbers that are in standard form. 182,463 compared to 182,643. I'm going to compare like units starting with the greatest place value. In my 100,000s place in both numbers, I have a 1. In my 10,000s place, there's an 8. In my thousands place, there's 2. In my hundreds place, I have a 4 versus a 6. So it is at this hundreds place that I'm really able to make that comparison, that 182,463 is less than 182,643, because 400s is less than 600s. 62 ones compared to 8 tens. I'm going to write these two numbers in standard form. 62 ones, I need 62 to end in my ones place. 8 tens, I want my 8 to end in the tens place. That means there are no ones. So I'm going to once again compare the like units starting with the greatest place value. I have 6 tens versus 8 tens. I know that 6 tens is less than 8 tens. So 62 ones is less than 8 tens. Next, I'm given numbers in expanded form. I'm going to go ahead and add these and put them into standard form. 2,467 compared to 2,407. So there are no tens, 7 ones. Now I'm going to compare greatest place values, 2 in both numbers in the thousands, 4 in both numbers in the hundreds, 6 tens versus 0 tens. 6 tens is greater than 0 tens. So 2,467 is greater than 2,407. Now I didn't have to write both numbers in standard form. I just like to be able to compare my like place values starting with that greatest place value. In the expanded form here, I could have also seen that both of my numbers have 200,000, both had 400, both had a 7, and so obviously the one on the left is going to be greater because it also had that 60. I can add and subtract multi-digit whole numbers. Use the standard algorithm to solve. I'm going to line my numbers up in a vertical form so that the place values are lined up here. 45,683. I'm going to add 68,158. And so I'm going to add the like units starting with my ones here. 3 plus 8 is 11. One of those will stay. 10 will bundle and make a 10. 1, 8, and 5 all in the tens place there is 14 tens. 4 will stay, 10 of those 10s bundle and make 100. In my hundreds column, I have 1, 6, and 1 for a total of 8 in the hundreds. Now I'm in my thousands column. I have 5 thousands and 8 thousands, which is 13 thousands. 3 will stay, 10 of those will bundle and make a 10,000. 1, 4, and 6 all in the 10 thousands place will make 11 10,000s. 1 will stay, 10 will bundle and make 100,000. And that added to nothing else will be 1 in the 100,000s place. So my answer to the addition problem, my sum, is 113,841. Now we're going to subtract, so we're finding a difference. Again, I'm going to line up my place values so that I can subtract like units. I have 723,184 minus 456,273. Starting in the ones column, I'm taking 3 away from 4. That leaves me with 1, 1. I'm taking 7 away from 8 in my tens column, so I'm left with 1 in the tens. I'm taking 2 away from 1. So here I start with 100 and I have to take away 2 hundreds. So I'm not starting with enough hundreds to be able to get 2 away from there. I'm going to go over to the thousands, borrow 1, which leaves 2 here, and then unbundle that 1,000 I'm borrowing, or rename it, and let 10 hundreds fall out, plus the one that's already here. That's why this becomes 11. 11 minus 2 is 9 in the hundreds. And now I have 2 in the thousands that I need to take 6 away from. Again, I'm going to come over. I'm going to rename one of my 10,000s. That leaves 1 here. And it lets 10 fall out with the 2 that's already there. That's why that becomes 12 in our thousands place. 12 minus 6 is 6 for the thousands. 1 minus 5. Again, I need to come over. I'm going to get one of my 100,000s this time, leaving 6. I'm going to unbundle one of those 100,000s and let 10 10,000s fall out with the one that's already there. And that's why we now get 11 10,000s. 11 minus 5 is 6 10,000s, and 6 minus 4 is 200,000s. The difference is 266,911. I can solve word problems involving metric measurement. The bananas Tori bought weighed 940 grams. Her apples weighed 1 kilogram, 720 grams more than the bananas. How much did the bananas and apples weigh together? I'm going to model this using a tape diagram here. The bananas, we are told, weighed 940 grams. The apples weighed 1,000 or 1 kilogram, which I know is 1,000 grams, 720 more grams. So we're going to put those together and say, okay, it was 940 grams that the bananas weighed and an additional 1 kilogram, 720 grams, which I'm going to rename as 1,720 grams. And so the question then is, how much did the apples and bananas weigh together? So I'm going to go ahead and add the 940 grams and the 1,720 grams to figure out the apples. I have 0 ones, 6 tens, 16 hundreds. We'll leave 6, let 10 of those hundreds bundle and make 1,000. And 1 in 1,000 is 2,000. So 2,660 grams is the weight of the apples here. Now, I haven't answered the question yet because it said how much did the apples and bananas weigh together. So we have our 940 grams for the bananas, and then we have our 2,660 grams for our apples. And so we're going to put those together, and we see that we get 3,600 grams. I can rewrite that if I want as 3 kilograms, 600 grams. So either one of these works. I can identify types of angles. Classify the angles as acute, obtuse, or right. I know that a right angle measures exactly 90 degrees. An obtuse angle measures more than 90 but less than 180 degrees. An acute angle measures less than 90 degrees. So my given angle measuring 45 degrees would be considered an acute angle. That's all for today. Math for